This conference will now be recorded.
So we have done with multi-threading. Sorry, we have done with collections. As I told you, I'll be starting you multi-threading. Right?
Hello?
Again, you lost my voice.
Yeah. Can you speak again? Now I just want to test.
Can you hear me now? Is it fine? Are you lost it now or?
Yeah, now it's good. Now it's good.
Okay, I think there may some. Please let me know when you lost it. Otherwise, type in the chat also, because otherwise, what I'll do, I'll continue telling. You may lost somewhere.
Okay.
Right?
Okay. Now it's okay. Yes. Yes.
Okay. So we have discussed yesterday that collection has been completed, and I told you I'll be starting you multi-threading, right?
Yes.
So I hope you are clear with the collections, and but please try to do more practices also. So there is a concept called multi-threading. I think you are aware. You heard this term, right? Multi-threading.
Yeah.
So what do you generally mean by multi-threading or multitasking?
Yeah. So I think it's like thread. You basically like in if it's a simple thread, like the efficiency is low, and
No, don't go with the. I'm asking general terminology. Don't go with a concept. We'll go with that. But generally, what is the meaning of multitasking? Generally, doing many
yeah,
things
but
simultaneously, right?
yes, multiple thread to execute at the same time.
Okay. So generally the meaning of multitasking. So so we do go to the thread concept. So general term, generally a multitasking is something where you do many actions simultaneously, right? You can see the image also there. So where a person does a lot of things simultaneously, right? So whenever we are right now also we are just trying to see the slide, understand something or write something, so that is also a multitasking that you do at the same time, right? So what is the purpose of doing multitasking? So when you do multitasking, what happens? There is a time period that gets reduces and it gets to increase that efficiency. Then to main the purpose is to reduce the time period that you do the task, right? So in the same concept in the programming also, you are multi-threading. So what is that? It is going to reduce the amount of time that you are going to work on some task. In case of your programming, when it comes to programming, the same thing. And Java executing multiple threads simultaneously, and your thread is something is the smallest unit of multi processing, and multi-threading or multi-processing, both are same. Obviously, you can consider it as same, and you can see what is a thread. I think you can able to read the slides, right? So is nothing but a small unit where it's an executable code where it will perform that particular task that you call it as a thread. And so when you do an application or when you have a program, that can be divided into multiple tasks, and each task can be assigned as a thread, right? So making many threads executing simultaneously is termed as multi-threading. Appears as a process that is running concurrently, but there is. So I think these points are very clear, right? So generally you have two kinds of multitasking. So I can say process-based multi-threading or thread-based multitasking. So so the main motive of this two processors is to make your processor give the zero idle time and reduce the time period and increase that efficiency. That is the main purpose that you do multitasking, right? So when it comes to the process-based, right? Uh, like in this process-based, you will have different threads will perform to complete your process, and one process is independent of another process. So you can take an operating system is like the proper example for the process based multi-threading. So for example, this is my PC. If you see, we have I have opened Eclipse, I have opened Notepad, I have opened a PowerPoint presentation, we are in Google Meet, we can open some folder, we can write something, and everything you consider it as a process. The PowerPoint presentation is a process, Eclipse is one of the process, but every process is independent, right? I can search something in a Chrome and every process is independent. And in each process, you have a different threads to complete that process, right? So that is the best example of your process-based multitasking. So I have given an example. If you see, every process, operating system, every process will have a different threads in it, right? So to accomplish this process, you will have, and the process one is independent of your process two, and process two is independent of your process. So that is nothing but your process-based multi-threading. So when it comes to thread-based multi-threading, when in single process you will have different threads and they are dependent. So depending on that process to complete that process, and your threads will execute some task to complete that process. So here they are dependency. So you can read the points for a process-based and thread-based. A process is typically independent and it has more states and separate address spaces. So you will have a different address spaces and interact only through the system, some IPC. And in thread-based subsets of your process, the thread, whenever it comes to thread-based, so that your threads are nothing but subsets of your process. To complete your process, you need small threads. And so all the threads will share the common state or a memory, and this share the common address space even, right? I think you are clear with what is thread based and what is process based. Any queries, Mike?
No.
So now in this we'll be discussing only the thread based, right? In our multi-threading concept. So this is the life cycle of your thread. So it is similar to the life cycle of a human being, like born state, runnable state, running state, and terminated state. So once we are born, we cannot reborn. So once we done die, we cannot die again, right? So same way, your thread will be born once, it will die once, but you have an intermediate state in between your born and die. That are as well your runnable, running, as well as waiting and sleeping. So runnable or ready is nothing but it's ready to start. Running is something it is executing the task, right? And in this you have an intermediate states. So we'll come to this again and again, and we'll see this more. And you have, this is nothing but a life cycle of a thread. That is nothing but your waiting state, runnable, running, the same thing here also. And so how you create your state. So this is nothing but a life cycle of your thread, and how you are creating your threads. So there are two ways that you are creating a thread: by using a thread class and by using a runnable interface. I think you are clear with the interface and this thread class, right? So that we will be seeing here. And in both the cases, you are going to override the run method. So we'll see this clearly in detail. So first we'll discuss how you create a thread by extending a thread class. Next we'll see with implementing a runnable interface. So I have taken a class called thread example, right? So in this class, assume that I have two methods. I will be taking so I think you have an idea of for loop, right? So it's like for example, I want to execute some part of the code for 5 times. I less than 5, I am taking I value as 0, and your I is less than 5 and I plus plus. So what I am doing, I am executing that. inside M1, right? So this is I'm executing. So I think you're clear with this. So I'm taking I value 0, and if the I is less than 5, what happens? It will go inside and it will execute inside M1 method. So how many times I'm executing that inside M1 method? 5 times. And what happens? It will come to this place after executing I plus plus. So I becomes 1. So it will not do initialization again. So 1 is less than 5, it will execute. 2 is less than 5, it will execute. I think you are clear with this one, right? So you let me know any doubt in it. This is my M1 method. So similarly, I just want to write a main method, right? And inside my main method, I want to execute the some for loop. So before executing the for loop, what I need to do, I need to call this method, right? I'm calling this. So I'm calling M1 method. So it's a non-static method. I'm creating an object and so similarly, I want to execute some part of code in my main method, the same for loop. So inside main method. So if it is 5 times or 10 times, right? So can you tell me what is the my output mic here? It will be simple inside M1 for 10 times. After that, inside M1 for main method, right? When you call your main method, and main method will call M1 method, and M1 method will execute this. So it will call ex.m1 and it will execute this, and after that, your main method will execute, right? So this is a simple output. You see inside M1 10 times, and as after inside M1 main method 10 times. No, in this case, is this both codes are independent, right? Executing this part of code is independent of executing this part of the code, right? Assume that this is a whole process. The whole thread example, assume that this is a process, right? In this process, now at this point of time, how many threads you have? You have only one thread. What is your thread? Main thread. So the main thread is responsible of executing this part of the code as well as this part of the code, right? Now, if you see this, there is no dependency of executing inside M1 and inside main method. It means I am not using I variable or I am not using something here to here, right? So this both pieces are independent, right? So what your main method is waiting until completing of your M1 method, executing of method for 10 times. Assume that it is not 10, it is 50 or it is 100 or if it is 1000, right? So until that time, what happens? Your main method will not execute at all, right? Whenever you are doing an increment or some operation, your main method is not executing. It means you are giving some rest, some idle time for the processor, right? Here, there will be some less time. To assume that if there is only single thread, assume that it is taking some 2 seconds. Generally will not take seconds, it will take micro only, right? Assume that it is taking some 2 seconds because your main thread is executing this, and whenever you have only one thread, and when after completing this only, your main thread will start executing your inside main method part of the code. Now, so
sorry, why do you mean there is an idle time?
Idle time, it means
yeah. Okay, yeah.
Yes.
For me, there is no idle time, like where it's flown. First, we execute M1, right? EXM1, and we have like 50 times inside M1, and then the logic will go to execute inside the main method, right? Like, oh, I don't get what's the point of idle, you mean?
Yes. So here internally you cannot see idle because you don't see any time lapse because it is going to execute in a very nanoseconds, right? So, but when you do a real-time application, this is not the scenario. For understanding, we are just taking this scenario, right? So, when you do a real-time application, there may be your processor. For example, when so you have a processor, you have a some code. So who is executing this code? Your processor is executing this code, right? So when there is some increment operation, for example, it is checking this increment, right? So this increment is checking not by processor, I'm talking it behind the scenes actually. So your processor may get some idle time. So whenever you have only one thread which is executing, so if there is an interruption, there is some checking, there is some initialization, some increment happening. So internally I'm speaking, there is a chance of getting a ideal time for your processor. It means your processor will be in a, it will not execute some part of the code. You are understanding me? It will be in a rest. Generally it will not be, but I'm talking in behind the scenes. So assume that there may be chance of getting an ideal time for the processor, right? So here what is the my point of time is, my point of view explaining is, whenever you are executing this inside M1 method, whenever you do this increment operation, whenever you do this initialization operator, you are executing that 50 times or 100 times. Assume that you are executing this inside M1 for 1000 times. You may have some part of the code. So whenever you have some executing some part of the code, the other part of the code, your main method, this code was not executing, right? It is in waiting state, right? This part of the code was not executing it. Your processor is not giving chance for this code to be executed, right? So it means it is waiting until completing of this for 100 times. So why it should, is there any dependencies of between these two parts, this code which you written in 7 and 8 and the code that you have written in 18 and 19? There is only, there is the, to execute this 19th statement, there is any dependency that was present over here? No. If to execute this statement, is there any dependency present over here? No. Then why this part, the code which is written here, should wait until completing of this? If you write for 1000 times, what will do, it will wait for 1000 times, right? Assume that there is an interruption come and it goes to somewhere, there is something happened. So but what happened, the code here will be in a still waiting state, right? Until completing here only, after completing this part of the code only, you are executing that. So why you want to make that, right? When these both parts are independent in this whole process, this is nothing but your whole process. Assume that this is the whole process. In this whole process, when there are two parts are independent, so why you can't you make a two threads? As of now, why I'm saying the way, what is the reason of creating a thread? I'm telling where you create a thread, what the thread is doing, right? So whenever you don't have anything, so by default you have a main thread. So main thread is responsible of executing this part and main thread is responsible of executing this part. So whenever these two parts are independent, why you want only one thread? You can create two threads. So then what happens, this two threads gets executed simultaneously and then your speed gets increased, the time gets reduced. So this is how you can do it. So this is what we learn in multi-threading, right? So here is a requirement, here is a chance that you can make two threads. When you have one thread which is executing two tasks, so it may take time. So what you do, you take two threads. So what happens, two threads will execute two tasks simultaneously. So one thread will execute this task, another thread will execute this task, right? So then they are both independent and your processor will not have any ideal time. So generally you are not having, but there is no chance it will get an ideal time. So there will be simultaneous execution happens. So here I can create a two threads, right? So as of now in this process you have only one thread, that is your main thread. Now what I want to do, I want to create two threads, so which will execute this and this independently. I think you got my point, Mike, right?
Yes, yes.
So to create a thread, so I need to follow some steps. What are the steps that I need to follow? First, I need to extend a thread class. So what is this thread? This is a predefined class, right? So that is present in your LAN package. And what I need to do, I need to override a run method. Instead of writing an M1 method, I'm writing a run method, right? Why this error is nothing but I need to make that run method as a public. I'm making that run method as a public. Here, you should not call run method. You should call start method. I'll tell you why you need to call start method. This is the simple way that you create a thread. So what I am doing in thread example exe, what you are calling ex dot start method. So where it will go to the thread example, right? Is there any start method present in thread example? No. So then what it will go? It will go to the parent class. That parent class will have a start method. So your thread will have a start method, right? And what they have written in a start method is they will register your thread to a thread scheduler. So you have something called thread scheduler. You have a thread scheduler and processor, right? So your processor is responsible of executing all the threads, right? So assume that when you do an application, you will have multiple threads, right? So when you complete the process, you have 10 threads or 20 threads, or you will have a multiple threads, right? So every thread want to execute. So, but which thread your processor has to execute, right? So that is decided by your thread scheduler. Thread scheduler is like a watchman or a gateway. What it will do, it will take a thread. That thread it will give it a processor, and that thread which is given by a thread scheduler will be executed by your processor, right? So thread scheduler is something like a gateway. So it is going to take care of all your threads, and it is going to give that threads to the processor, and whatever the thread given by the thread scheduler only your processor will execute. Now by default main thread JVM, when the Java people have given the created a main thread and they have registered the main thread for a thread scheduler. Now as a user you are trying to create a one more thread, right? In application you are trying to create a one more thread because of now for your requirement. So this thread has to be registered for your thread scheduler, right? So then you are not writing any code to register for thread scheduler. You are not doing any part of the code. So then who is going to do that? The Java people only going to do that. So where they are going to do that, they are going to write that particular, assume that they are going to write that everything in a start method. So they are going to register your thread scheduler, and they may do some stuff, right? And don't worry what they are going to do. And they are going to create a thread for you. So, and they are going to call that start method is going to call the child class run method where you return the logic, right? And that's the reason you should not call a run method, you should call a start method. And where this start method is present, that is present in the thread class. If you see, as I told you, there is a Java API, you can see all the predefined methods, Java predefined methods. So thread is also a predefined class, and in that you have a predefined methods for start and run. So in run method, you do overriding. What is the meaning of overriding? Writing a same name and same signature, and you call the start method. And that start method will create a thread, will register your thread scheduler, and it will do all the initialization activities, and it will create a thread for you. And what it will do, it is going to call the child class run method, the run method that you written in the user defined class. So where this thread class is present, it will be present in LAN package because we have not imported anything. So by default, the import package is LAN. So you have a predefined classes, you have a predefined method, predefined class called thread. So thread is a predefined. So if you see, thread is also a set of object. Whatever the class, that is a child of your object class. And what it will thread do? Thread will do implementation of runnable. So we'll see what is this runnable. So these are the fields that are present. These are the nested classes. So these are the constructors that are present in your thread. So thread zero parameter, thread with runnable, thread with string. So these are the predefined constructors we present, and we have a methods. So what are the methods that we see? So there are a lot of methods, but what we are discussing right now is about run as well as start, right? If you see, there is a run method. You can read the description of the run method also. So this run method will not return anything. So why they have overridden run method in the this thing is nothing but this is the run method is present in your runnable interface, right? So thread is the one which extends runnable. So if any class that extends an interface, what it has to do? It has to override all the abstract methods. So similarly, thread has overridden the abstract method run present in your runnable. So runnable also a predefined one, that is an interface they are given. So you can see a start method. We'll see sleep method. We'll see lot of methods. So you can see there is a start method that we are calling. So causes this thread to begin execution. The Java virtual machine calls the run method of this thread. The JVM calls the run method of this thread. So run method of this thread. So it is going to call the run method of this thread means thread example. Can you consider? So this run method is get called. So your start method.
So the start will call a run.
Exactly, Mike. The start here you call a predefined start method. So that start you call your run method. Why you are calling it start method? As I told you, to make to register your thread to the thread scheduler. Like that, you can say you can assume.
So you mean because of the thread scheduler, so then the start can call a run, something like that.
I'm telling you. Internally, these things will happen because why they are calling a start method? Because whenever you want to create a thread, you need to register for thread scheduler and you need to do some things. Don't know what Java people are doing. You don't know how to create a thread. Don't worry. So they have already done it. So what we need to do, we need to use the predefined methods, right? So we are using it. That's it. So we will call the start method.
So for us, we just remember to use this way, like to start to call a run, and that's it.
Yes. So don't worry how they have done it. It's not our part. So I'm telling why you are calling it. So that will do. There will be some part of the code they have done it in a start method, and that start method is going to call the particular.
I see. It's something internally.
Internal, yes.
And so just what is a thread scheduler? Like it's a like an internal, also an internal program, like in Java, like the Java creator, Java guys, they created it.
It's like internal concept itself. Like it is not related to Java. It is related to operating system. So, for example, here also multi-threading is not related only to Java, right? So, for example, whatever that process that you
Maybe
see,
C#, like C++, they also have multi-threading.
there are a lot of things that is behind our scope, right? So, like your processor is running based on multi-threading, right? So
yes.
all these are, as I told you, all this is nothing but your processor. Internally you have a different threads. So how assume that when you take a PC, you are trying to do lot of things simultaneously. Why? Because there is a multi-threads. Multi-threads are responsible to do that action simultaneously, right?
Yes. Okay. Okay. Thread scheduler.
Give me-
So thread scheduler is a OS operating system like thing.
It is related to that. You can consider that is
It's
related
not.
to that.
It's not like. It's not like based on Java.
No, no, no. It is not a Java part. I'm
Okay.
just telling you like that. It is a gateway when you want to create, you need to do this stuff. That's what I'm telling you.
I
Right?
see.
Give me a minute. I'll get a charging. Give me a
Sure.
minute.
Okay.
నీ ఆ భర్త ట్రీట్మెంట్ తీసుకుంటే అయిపోతుంది కరోనా ఏమున్నది. Can you hear me, right?
Yes.
So here, this is a simple way that you are creating a multi-threading. Now what happens when you call a start method, the start method is going to call the start method. So the run, it is going to call this run method, and now what happens, these two things will execute simultaneously inside M1 and inside main method. So now what happened, there are two threads created. So there is one thread which is executing your main method, there is a thread which is executing your main method, and there's one more thread that will execute your run method. So there are two threads which act on this and execute simultaneously. So there is no guarantee which one will come. So it is happening doing that it is coming serial, but it will not happen serial every time. It will be simultaneous.
You mean the sequence?
It will not be in a sequence. Inside 50, it will not be 50 times. It will be total times will be 50. If you see, now you see simultaneously. First, what happened? Your main thread got started. Now what happened? It given the chance to the child thread and your child thread. Assume that there are two threads. The code that I have written in main method is main thread, and inside M1 is a child thread, because that this is nothing but we created thread. So this is nothing but already the thread is present.
I see. Because so now they are not in sequence because they are running at the same time.
Simultaneously, multi-thread.
Yes.
Again, what happened? Your main thread got a chance, and it started executing. Again, I think if your child has not finished, again your child thread's got a chance. And if you run it for the second time, it will not be the same. It may be something different. Because simultaneously, it all totally depends on the processor. You don't have the guarantee which one will come first, which one will be next. Your main started executing, and your main inside M1 again in main, right? This is what your simultaneous outputs. You got that concept, right? So this is nothing but your simple way of creating a thread. Right. And assume that if you call the run method here directly instead of calling run method, so now it becomes as a multi-threading mic. If I call a run method here, so now it becomes as multi-threading.
Yes.
No,
No.
because
Why?
because you are calling which method? You are calling run method. So what it will do? It will create normal Java program, right? It will execute for 50 times. After this will execute for 50 times. You are not calling the start method that is present in the thread class. So that start method is
Okay, okay. So yes, yes. We must call at the start at the thread level.
yes. So that is responsible of creating a multi-threading, and that will execute simultaneously. If not, it will act as a normal program, and it will until completing of this 50 times. This will be in a waiting, right?
I got, yes, I understand now.
So this will not be a simultaneous execution.
Only when the start use
Yes.
the
So
start.
that is creating a
Start
thread, right?
you only when you use the start method, basically.
Yes. So if you see, it is executing M1 50 times and main method. It's a normal Java program. There is no.
Yeah. And in sequence.
There is only one thread. What is your thread? That is nothing but your only main thread. So main is executing this. After this, only you are executing. So there is no two threads created. So when you call the start method only, right? So that will do the simultaneous execution. So you don't guarantee what will happen. So see, main started, again M1 started, again main started. So there is a simultaneous. If you run again, it will be something different. Assume that you have overridden a start method, right? So similarly, assume that I have a run method, right? So similarly, I'm trying to override a start method. Now, what is an output?
We don't need to write a start method. I mean, we don't. It's not necessary to write, right?
No, it's not necessary. We no need to write it. So I'm telling, if I write like this, what is
But
my?
you
I'm overriding. So this is a start method. So in thread, you have two methods. One is run method and one is start method. What is the method that you need to override? You need to override the run method. So in this case, what I'm doing, I'm overriding the start method also, right? And if I run this, so now my question is whether it will act as a multi-threading or it will be child or main, or what is my output, I'm asking.
now you are right. Start method. But okay, let me see. Now you write a start, so it go here. So just give me 1 second to think. It's like now when it's go start, it will run
Well,
this one. I think it's if you write like this, it will not be multi-threading.
okay, what is my output?
Your output will be the start method. Your output will be same as the regular one. 50, I think it's 50, like inside the M1 and then inside the main method.
Once again, see.
I mean, it will be so you run start, but the start method is empty, right? Yeah. If it's empty, there is nothing. So that means your That means your result should be 50 inside the main method.
Exactly.
Right?
Yes, Mike.
Can you run that?
Exactly. Whatever you said is right. So because there is no multi-threading, so why the run method is executing? Because there is a start method that is present in the run method is calling. Now you overridden a start method. Now obviously it will not create a multi-threading. And what is the normal Java program? It will come and it will come over here and it will execute inside main for 50 times. So no one is calling your run method, right? So why it will execute? It will not execute. That's it. What you said is exactly right.
Can you? Yes, please run.
Yes, yes. It will be whatever you said only inside 50 main only will come. Child will not come.
Oh, okay, that's right. So this program will not go to that the inside the M1. It will not go that code.
Run method. Yes.
Yeah, it will. I mean, it will. Yes, it will not go to run method. Basically, it will ignore this part.
It's normal Java program. If you write some method and in Java you're not calling this, why do you execute? It will not execute.
Yeah,
right?
yeah. But yeah, there is no error, but it will not call it.
Yes, exactly. It will be simple.
My God, this thing is, yeah.
Yes. And so you can see this slide for once for 2 minutes. So whatever, like extending a thread class and overriding it, implementing the run method. And you can see that example also. And there are two ways. One is by using a thread class and the way of creating a threads. So we have seen by using a thread class. Now we'll be seeing by using a runnable. So the concept is so actually you have some runnable interface. You have interface that is nothing but runnable, right? And this is not an interface mic. So what your interface is having, it is having an abstract method called run, right? So this abstract method run, so any class which is implementing, so with this runnable interface, what it has to do, so assume that you are is a thread class which is implementing your runnable interface. So this the thread is, what is this? Thread is a predefined method, right? So this what it is doing is implementing your runnable interface, right? So whenever any class that implements an interface, what it has to do? it has to override that abstract method. What is an abstract method that is overriding? It is overriding this run abstract method, right? So there is only one method in runnable interface, that is only one run method. This is also a predefined, this is also predefined class. So your thread is implementing runnable, and what it is doing, it is overriding the run method, right? And in this example, what we have done, we have extended the run class, sorry, extended the thread class, right? And we created our class. What is our class? I created some class name called thread example. I created a class called thread example. Now in this thread example, what I am doing, I am writing a run method and I am writing my own logic, right? So the run method which is present in the thread class is empty. It will not return anything. There is no code they have written it, right? So here what you are doing, you are writing the user logic. Your logic you are writing, and what you are doing, you have a, here also you have a which method in this thread class, also you have a which method, you have a start method in the thread class. So you have a start method here, right? And from this thing, what you are doing, we are calling the start method from this thread example. What I'm doing, what we have seen, just I'm trying to represent in a diagrammatical way. So we are calling a start method. Which start method we are calling? We are calling the start method that is present in the thread class. So what this start method is doing, so this start method is going to call which method? It is going to call the, after executing is, it is going to call the run method that is present in the thread example. Is this clear, right? What I have done, right? So this is what we have done, right? So this is the first way of creating your thread. Now, what is the second way that we are doing? We are, instead of extending it from thread class, what we do, we implement a runnable interface. It means runnable interface. So otherwise, I'll take one more example. So this is nothing but a thread example by doing this, right? Okay, everything was written already. No need to change it. So with thread example 3, what is implement is runnable. Then what I need to do? I need to override this run method, and I'm doing the same thing. And I am creating this thread example object. Thread example object, right? So thread example 3. So what I need to do, instead of, so here thread is implementing, right? So instead of that, what we are doing, we are manually implementing this. So who is implementing this? Thread example 3. Thread example 3. All right. So whenever I do implements, what I need to do here, whenever in this case, overriding of run method is not mandatory, but here overriding of run method is mandatory, because when we are doing abstract implementation, interface implementation, we need to override the abstract methods. So overriding of run method is mandatory. If you don't override it, it will show me error. In this case, it will not show me an error, right? So if I don't override it, so if you see, it will show me an error, because it will ask you to add an unimplemented method, right? So that overriding is mandatory here. So I am creating an object of which thread example ex. So can I call ex.start method, Mike? Can I call start method like this?
No,
Why? Because
now it's runnable. It's not a thread class.
pardon, can you tell me again?
Because now there is a runnable.
Yes, it is not a thread, right?
Yeah, it's not a thread.
Before case, what happened when you call a start method? Why it has not shown an error? It will go to the parent and so it will go to the current class thread example, and if the start method is not there, what it will go? It will go to the thread class. The thread class has a start method, then there is not an issue. Now, if I call a start method, is the start method present here? No. Then what it has to go? It has to go to its parent. So implements runnable is a parent. So runnable is not having a start method. It's an interface. It has only which method? It has only run method. So now you cannot call the start method, right? So then what I need to do? I need to, so where the start method is present, there is a thread class start method is present. There they have written a logic to create a thread, and then I need to call the thread class start method. So then what I need to do? I am creating an object thread th, and I'm calling new thread like this. If I do, assume that I am calling th.start. Now it will act as a multi-threading, or it will act as a normal. Can you tell me now what happens if I do like this?
Yeah, it will not go for multi-threading.
Why?
Yeah, because there is no thread class.
Thread class is there, right? Thread class I'm calling.
But no, at the top there is only runnable.
Runnable.
Yeah, there's no thread class.
The point is here there is no relationship between your thread example and thread, right? So in this case, when you call a start method, there is a relationship, and that's the reason that start method can able to call that current class run method, right? Here in this case, there is no relation, right? So it means it cannot call this run method that is present in your thread example 3.
Yeah, there is no relation. You
Right?
cannot.
So here, for example, if I create a thread object and if I call a start method also, how it will call run method? There should be run relation, right? So before, how you created an object, as I told you, a thread is you will have a different constructors, right? So how I created an object in before case, I created an object with 0 parameter, right? Allocates a new thread. So this is the one which is going to allocate a new thread, whatever the constructor that is going to allocate a new thread. So this is nothing but allocates a new thread. Now in this case, I cannot create an object with 0 parameter of the thread. So what I do, I create an object with 1 parameter. What is that 1 parameter? Runnable. So the parent can hold the child object, right? So I'm going to create an object with this. So in this, what is the reference I'm going to pass? I'm going to pass the child reference, so that for that it is going to create a thread, and so allocates a new thread. So what before case it is going to allocate a new thread, right? So for this before case for which it is going to allocate a new thread, it is going to create a thread for this thread example, the e.start method you are calling. So whenever you are creating this object, what happens? So for example, this is also constructors. So when I create the child object, what happens? First, it will create your parent object. So indirectly, if I create this, which object is creating? It is creating this object, right? It is creating this object. It allocates a new thread, right? So in this case, what I need to do, I need to create an object with this one parameter, and in this one parameter, what I'll pass that object reference. So here in runnable interface, I will not create create the thread with the 0 parameter. I'll create with the one parameter object reference. So now which constructor it will call? It will call this thread with runnable. So runnable is a parent. So then what it will hold? It will hold the child. Ex is a child because it's a child of runner implements, right? So this is now your dynamic polymorphism. Like interface can hold the child objects. So runnable is the interface which can hold your child object. This is how your runnable polymorphism works. So when I call the th.start method, now your run method is getting called and it will act as a multi-threading. If I run, it is going to act as a multi-threading. So if you see, main started first. Now given chance to the child. Again main started executing. Again given chance to the child. So this is what your multi-threading, right? Simultaneous execution. So if you run for the second time, it may be something different. So there are two ways of creating a thread. So first it started main, again child, again main. So this is your multi. So there are two ways of creating your threads: by extending thread, by extending runnable, by implementing runnable. So we'll see the difference also. But I hope you understood what is the two ways.
I need to. I will review it. So
Okay.
then okay. Thank you. I will review it and then
Okay.
we can discuss.
Okay. Please go through the recording also once again, so you may get some more clarity.
Sure. Just can we because I have the weekend morning, I have some family things, so can we continue like next Monday 10 a.m. same time?
Okay, fine. So you don't want to classes on this weekend, Saturday and Sunday, right?
Sorry. I like for this week's because I have to handle some family things. So
yes. So we'll continue on Monday. Yes, no issues.
Okay.
So general timings of our classes is like we'll have it Monday to Saturday, right? Monday to Saturday or Friday. So we are taking it on weekends because there is some missing happens. We are taking it on weekends or Sunday. So generally we don't have class on Sunday, right?
Yeah.
If there is any miss if I miss the class or like if there's some emergency I missed it, we are just compensated. We are taking on Saturday.
Yeah, sure. But I think the process is we are making is good. Like at least we make like 4 or 5 like a session each week.
We
didn't.
So
we didn't meet a lot. So I think it's still good progress. So we just continue. Yeah.
Yes. I just want this. Like at least we need to meet like 5 days. 5 days should be
4 or 5. That's right.
So I think mostly we are making 5. You can see the things that the day we have started, there are few missing happen. That's it.
Yes.
So we are even compensating on Saturday and Sunday also.
Yeah. Okay.
Have a nice weekend.
So thank you. Yeah, have a nice weekend. So we will connect next Monday.
Yes. Thank you.
Okay, bye. Bye for now, Suya.